Well, I'm Roger Hoopingarner, if those of you who don't know. I spent 38 years at Michigan State as a extension specialist in bees and honey, among other things, and retired 12 years ago. And what I wanted to do was get a basic bee biology kind of course. And so I suggested it to Mike, and he said yes. And so originally I was going to do it for 30 minutes before the meeting, and he said, no, let's do it during the meeting. With that caveat, I was reminded of a professor who once told me, he says, beware professors, they talk in 50-minute blocks. Yeah. So, all right. What I want to do today is kind of give you some background that's not really biology, but in part it is. It's a lot of taxonomy, and it tells you about bees. And so let's go, Mike. What's in the name Apis mellifera? That is the name of the honeybee. Okay, let's go. Carl von Linné was a Swedish botanist in about the 1730s, developed a system of nomenclature for plants and animals, and he published it in a series called Systema Naturae, which is natural systems. And he thought Latin was the language of scholars and scientists, and so he made everything in Latin, including his name, became Linnaeus. Okay. And he decided that everything would have a genus and a species. Apis is the genus, and mellifera is the specific name. So that identifies that particular animal or plant very precisely. Now there's higher classifications, family and orders and kingdoms and things like that, but this is the identification of a particular group or species of animals. Okay. Now, over the years, there's an International Commission of Zoological Nomenclature which has decided that the 10th edition of this Systema Naturae is the base. This is where everything finally came together as far as Linnaeus was concerned, and so that is the foundation for all of names. And why is that so important? Well, the name Apis mellifera in Latin means honey gatherer, and Linnaeus decided that was really wrong. They were a honey maker, and changed the name to Apis mellifera. Yeah, but that was in the 12th edition. And the international nomenclature said, nah, 10th edition's the base, everything else is in synonymy, and that's why the name stays with Apis mellifera. Okay. Also, you'll find in the books, literature, honeybee, 2 words, honeybee, 1 word, and honeybee hyphenated. They're all right. It turns out that the North American, or actually Entomological Society of America, North America, has decided that if an insect is what it is, then it's 2 words. And since bee is a bee, it's 2 words. If it was not, it would be like, say, butterfly is not a fly, so it's 1 word. So that's why in the North America you find it 2 words. In Europe, you find it 1 word in most dictionaries. Your spell check on your computer will have it as 1 word because they use the Oxford Dictionary. Some of the older literature has the hyphenation. Okay. Okay, the genus Apis is the honeybee Apis, or the Apis is the genus of the honeybees, okay. Apis mellifera is what we call the western honeybee. It was originally found in Africa, Europe, but is now worldwide, and it has multiple combs and a cavity nest, okay. Apis cerana is the eastern hive bee. It's found in Asia, Indonesia, the Philippines, Japan. Again, it has multiple combs and is a cavity nester. It's a little smaller. It's about 2/3 of the size, maybe 3/4 the size of Apis mellifera. Oh, I should add, there are some sibling species of this found in some islands in Indonesia, but they're not real common, so I'm going to ignore them. Apis florea is a small bee, single comb, single exposed comb, hanging down from a limb. It's found in the Middle East, roughly. Sometimes it skips over into things like Pakistan, but it's basically the Middle East. All right. Apis dorsata is the giant bee. Again, a large single exposed comb, and it's in Asia, Indonesia, and India. Very big bee, about the size, the workers are about the size of our queens. Pretty fierce, pretty hard to manage, though the natives do collect honey from them. These nests are sometimes 60, 70, 80 feet in the air. They shinny up these trees at night, flame off the bees with a little smoke, cut off the honey, drop it down and to a bucket down below, or carry it down the nest. These beekeepers have a very short life. I might add that these two, and it's curious to me, these two single comb nesting bees have half the set of chromosomes that the mellifera and cerana hive cavity bees. Okay. Now, Apis mellifera has what we call subspecies. Apis mellifera was found in northern Europe, and this is how come it became the type species, because Linnaeus was in Sweden, where this bee was. We have called it mostly the German brown or German black bee. Okay. Apis mellifera ligustica is the Italian bee, and we imported that starting about 1859. Okay. Apis mellifera carnica is basically the Alps and east of the Alps. The Carniolan bee, mostly a slightly darker bee, the Italian, of course, being yellow. We'll show you some pictures of those. And then Apis mellifera caucasica, it's in the Republic of Georgia, or Caucasus Mountains. And the Caucasian bee is, I'll show you, we think of it as a black bee. The Georgians don't. They have both black and yellow. Okay. And I put this one in, and I'll show you some others. But Apis mellifera scutellata is from South Africa. And this, of course, is the African bee that we have imported into South America and now moved up into North America. Okay, we don't have a pointer. If you look up way up here, this is the Northern Europe is the mellifera, and that is where the range of the native German or black bee that was the type species that Linnaeus gave the name to. Ligustica in Italy, Carnica here in Eastern Europe, in the Alps, Caucasica, the Caucasian bee here again in Georgia. I'll point out some others. Lamarckia, this is in Egypt. We did do some importing of that way back. And maybe the other one, here's scutellata. And if you look in some of the early literature of African bees in this country, Adansoni was given the name, subspecies name, but they did some analysis, some morphological analysis, and decided, no, the bee that was imported into South America was scutellata. So they threw that one out and said it was synonymous, but wrongly named. There's one way down here, the Cape bee, Capensis, and tip of was the tip of Africa. It's now spread a little more. It's notorious because the workers were often become laying workers and fertile laying workers. It's not a very good bee. Okay, Mike. Now, New World imports, the first recognized importation of bees into this country, into this hemisphere, was in 1638. The first time it was on a manifest. It's possible that it came before that, we just don't know. In fact, there's some speculation that it came over with the Vikings. The Vikings at that time were Christianized, and beeswax candles were important to the altar. Did they come? We don't know. But for more than 200 years, that was the only bee in this country. And then in 1859, Langstroth, Mahan, a few others decided that through the literature and reading that Ligustica, this Italian bee, was the bee that they wanted to import, and they started importations of bees. Next, Mike. And from 1860 until 1922, there were many, many importations. Fact is, the U.S. government sent Frank Benton to Europe to send queens back. The first queens that came back came as the whole hives. That's the only way they could get them back. 3 months on a ship. I mean, that's why they had to do it. But the Italians, and in fact, Benton really became enamored of carniolans, and he, in fact, took up a business and started shipping back carniolans. Caucasians, not really a lot of them imported, but some, and a few Egyptian bees. In 1922, the United States and Canada closed the border because of tracheal mites. Actually, at that time, they called it Isle of Wight disease. And it wasn't until sometime after they named it, they realized that it was this tracheal mite. And it was found in England and Europe, and so we just decided to close the border. And for a good many years, that barrier, as it were, worked. But in the 1980s, maybe probably before, but in the 1980s, tracheal mites and varroa mites entered this country with illegal importations. I mean, somebody brought them in. We don't know who, but somebody. And sometimes these were innocent people. They went to Europe, traveled around, and stopped and visited their second cousin 3 times removed in England or wherever. And, oh, I got some bees. You got bees? Oh, let's go look at them. And they looked at them. Boy, these are nice bees. And, well, I got an extra queen. You do? And so they gave the queen to him, and he sticks it in his pocket. The next day, he jumps on a plane at Heathrow and flies to the United States. And he gets to the border, and they say, do you got anything? Oh, yeah, I've got this doll from Russia and this stuff and this. And forgets about this bee he's got in his pocket. And he gets home, and he takes off his coat. Oh, I got this bee. And the next day, he puts it in his colony. Well, tracheal mites, varroa entered the country. Or whether that's the way it happened, but it happened. Same thing, Nosema serrani was obviously an importation sometime prior probably to 1990, but certainly by 1990 it was here. This is a protozoan parasite found in the gut, new Nosema. Okay, Mike. I put this one up. These are Caucasian bees from Georgia. I took this picture about 2 years ago when I was in Georgia, the Republic of Georgia. And this was in eastern Georgia, east of Tbilisi. And I visited, this is a queen, actually, a queen breeder, and royal jelly producer. And these are, you can see, banded. They're maybe a little dark banded, but they're dark. And I said, that's interesting. I said, in the United States, we consider the Caucasian bee a black bee. He says, oh, those are from western Caucasia, or Georgia, so over by the Black Sea. And so it's obvious where we imported our Caucasian bees from. Okay? And of course, this is an Italian, the banded Italian, light banded Italian. Okay? All right, a little bit about the genetics. In 1950s, Will Roberts, got to work with him as a student, identified 8 major genes responsible for the coat color in bees. Okay, Mike? He took a banded Italian queen, and then through selecting of drones and instrumental insemination, he backcrossed, and he produced golden Italians and black Caucasians, or black bees, from the same parent. Okay? I'll add this comment. Virgin queens mate from 12 to 20 drones, which brings up the question, do we have Italian, Carniolan, or Caucasian bees anymore? Let's go on a little bit before we answer that question. The Apis mellifera has 16 pair of chromosomes, or in the diploid state, so the workers and queens have 32 chromosomes. Drones are haploid, or N, and thus show the recessive genes from queens. Genes on a chromosome are linked and thus tend to be passed together on the same chromosome. It's just the way that DNA lines up. They have a tendency, the traits on one chromosome tend to stay together. However, we'll go on. As you know, mostly stock selection in this country has been based on color. Okay. If we look at pairs of chromosomes from the parents, occasionally they will they call crossover, in that when they're being replicated, one arm of one chromosome will cross over with another. And these have a tendency to do this further and further away from the centromere. And as a consequence, when they are mature, you get these chromosomes that differ from the parental type because they have apart from, say, the mother and apart from the father. Okay. So if you, and this is a diploid organism, so it's not quite property for honeybee, but as you can see, you can end up with some what we'd call different chromosomes because they have two parts. And if you look at this, it's about 80% here and about 20% here. So mostly you get the parental types that persist because these chromosomes have a tendency to, or genes, they stay on a chromosome and they tend to stay there and are linked, as we call them. Okay. Apis mellifera tended to be dark. They weren't really black, but they were dark bees. Pretty fierce. When I first started keeping bees more than 60 years ago, we'd run into them every once in a while. And you wanted to be suited up pretty well when you saw them. They were pretty fierce. Apis mellifera ligustica, or the Italian bee, are yellow-banded bees. And they were right to be from the beginning, and it was one of the things that we could select for, of course, was the yellowness, if you wish, or the banded nature of the bee. This one we passed. Selections, there we go. Selections are not perfect, but they worked, mainly because of linkage. In other words, you had the yellow colored on one chromosome, and the genes had a tendency to stay with it. If they were black, they had to tend to stay with that. Okay. In fact, there's a recent analysis, I'd say 5 years ago, maybe a little more. They did a comparison, and they found, by using DNA analysis, very little Apis mellifera genes left in the United States. And that's really curious. This was after Varroa. So all of our feral colonies had been taken, or most of our feral colonies had been taken out. And as a consequence, maybe that gene pool helped, or didn't help. But we have selected for Italians pretty much in this country, and they've done a pretty good job, simply by probably selecting on color alone. Okay, interesting enough about the Italian bees. My mentor at Michigan State for many years, Dr. E.C. Martin, or Bert Martin, told me in the 1930s in Ontario, they recommended requeening with Italian bees to stop European foul brood. That was a big program, in fact, supported by the provincial government. By the 1960s, Italian stock in Michigan no longer control European foul brood. So obviously we have lost something of the Italian stock in 30 or 40 or 50 years. The beekeeping community no longer has a large genetic buffer of feral colonies. And unfortunately, that is a big loss to the beekeeping community. That was a big reservoir of genetic diversity, a buffer, if you wish. Sometimes we don't recognize this loss in our modern beekeeping, but I think it's one of the things that's causing some of our troubles. Okay. Selection for favorable traits should be easier because this buffer is gone, but it's going to be less stable because we don't have that pool out there to keep the traits refurbished. So the bottom line, do we have pure Italian bees? No. They probably disappeared about 1861. Can we select for Italian color and traits? Yes. Simply because of that linkage to color on the chromosomes. And we've done a pretty good job. Instrumental insemination could help and may help and maintenance of a strain, and that's really the only positive way to do this. In fact, Sue Colby, now in California, has been selecting and maintaining a Carniolan strain for some years, including importations from Europe. That strain is probably the most pure stock we have in this country, simply because of that instrumental insemination and maintenance of that by her. But selection has to be continuous. That's all right, Mike. It's not big. There we go. That's something that we sometimes forget. It's just constant, continuous, never stop, never giving up, never pausing. You think you have it fixed in your stock? No, you don't. It's going to drift. It'll move because of your neighbors, because of some feral bees, because of the trait you're trying to select for is not that favored. Okay, questions? Yes?
Yeah, when you talk about the genetic buffer of feral colonies, you mean wild colonies?
Wild colonies. When you ask about feral bees, I mean wild bees. Right. Yeah. Trees in the forest or houses in your neighborhood. They generally have to have a cavity.
Provided a shield against the EFB then?
What's the question?
That provided a shield then? Those wild bees provided a genetic pool to act as a shield then against European foul brood?
No, the question was, did this feral population of bees provide us genes for controlling AFB and EFB, and no, but they were a buffer for variation. They had a pool of genes out there that we could use and select. We didn't get into the genetics of sex in honeybees. It's a little complicated because it's not the X and Y that we find in mammals particularly. It's a sex locus. And to simplify things, the pair of chromosomes have a sex locus on us. And they have to be heterozygous. They have to be different on one chromosome pair to the next to be a female. If they are the same allele paired, they are diploid but die. Drones being haploid only have one set, so it doesn't matter. People talk about haploidy is what causes sex in honeybees. That's not true. It's the chromosome itself, gene on a chromosome. Yes?
So if we're ordering a Carniolan or an Italian honeybee or, queen or whatever, what are we getting? I mean, because you're saying that essentially there are no Italians, there are no Carniolans. I mean, I guess I've never looked at them side by side, but...
There are people, beekeepers, who say, no, we don't have Italian bees, and we don't have Carniolans, and we don't have Caucasians in this country anymore. I mean, for 200 years, they were the German black bee. And then, of course, we imported Italians, and they were so good compared to, they were so gentle, really, so compared to the Apis mellifera, that everybody wanted them. And I mean, everybody. And so they just went over the country in a flash. But there's a lot of beekeepers who say, no, I don't have Italians, I have mutt bees. I mean, they are, and to that extent, this is what I said, that's true. I mean, there is no pure Italian anymore in this country. In fact, the U.S. government won't let me go over to Italy and send you some queens. I mean, it's still, that 1922 law still exists. It doesn't mean I can't maybe sneak them in, but I mean, I can't do it legally.
I don't know if this is what you're talking about, but I noticed on my eyes, if I stand there and watch them, that I have multicolored workers coming in and out.
Yeah, Mark, you're right. If you look at your colony, not every colony, but they often have multicolored workers and multicolored drones. You'll have drones that from yellow to black coming out of the, well, it's because the queen has been mated with lots of different drones, and so it's reflected in her drones, her offspring. Yeah.
I'm going to estimate about 30 years ago, there was a chaos. Was it 767 or?
Well, actually, Bud Kale lived from about he died about 1975. He was Dadant. He was a breeder for Dadant. And he produced, Bud Kale produced the Starline hybrid, which was an Italian bee, and also the Midnight hybrid bees, which was a Caucasian-based bee. And they were produced and sold to breeders. And then late in that period, they developed what they call genetic systems. Operated, was in your video. Yeah, Larry, for out of LaBelle, Florida, for a few years doing instrumental insemination of bees to maintain that hybrid status. And the problems were of introducing instrumentally inseminated queens plagued them right from the beginning. They're very hard to get introduced, and so they got killed. And as a consequence, the system, genetic systems went bankrupt. So went out of business.
So do we have a new name for the mutt?
We still call them, do we have a new name for the mutt? We still call them Italians, And that's not bad, because they have, because of that linkage, they have a lot of characteristics that we think of as Italian. And I did notice in this country when the tracheal mites came into the country, that our bees darkened up quite a bit, because it seems that the darker strains had more resistance to tracheal mites. And so you could just see that darkening of our bees. We haven't seen that in Varroa resistance. In other words, the so-called buckfast are really, so that selection didn't, the tracheal mite resistance didn't carry over to the Varroa, at least that we see. But there is a little darkening. But there's still banded yellow bees pretty much that we see. And if you went to Italy and brought another one back and put them side by side, would you see the difference? I suspect so. Simply because these crossovers do exist and do happen. And so what was the genes for Italian are now on the same chromosomes with the genes for Carniolan or Caucasian. Yes?
I got some they call them Italians, and they're light, and I can tell it, and they're gentle. And then I have some of the guys that they come from a Russian, and they're real dark, and they're kind of a crankier bee. Are they Russian? Is that?
The Russian bees, the question is between Italians and Russians, are there differences? Russians were probably mostly Carniolan base. They came out of Europe, were moved to eastern Siberia, where Tom Rinder picked them up.
Yeah, because they're supposed to be.
Yeah.
They're supposed to be more mite.
Yeah. Well, as you see, the Varroa mite that we know it in this country, Varroa destructor, probably evolved in Korea. Now, that's Dennis Anderson from Australia's best guess. Okay, right next door to where these Russian bees were moved, about 1950. And so they have had 60 years now of exposure to Varroa. We've had 25. So we're hoping that these bees have a lot more resistance to Varroa.
More resistant, but they're crankier.
But the crankiness or meanness, I think, varies a little bit with strains. And I think there are like a dozen now strains of Russian that have been imported.
They're darker. The ones that are crankier are darker.
Okay, okay. Now that's interesting because if you go to Europe, Carniolans have won the war in Europe. Almost every colony you find in Europe is Carniolan. And they're very gentle.
And they're darker colors.
And they're darker. So I suspect what it amounts to, if you go back in my history, in late 40s and 1950s, our bees were much, much more defensive, is the best word to use, than they are today. I mean, every colony that you examined, you expected to get stung. I mean, it was just kind of routine. You can buy stock today that you just rarely get stung. And that's because of that continuous selection for gentleness. And we haven't done that with the Russians. These people, I think, didn't care so much. We do, and so we have a tendency to select for that gentleness. Interestingly enough, this is again 40 years ago, there was a convocation at one of the national beekeepers meetings where the bee breeders asked the commercial honey producers what they wanted in their bees. So it was a roundtable kind of discussion. What was number one? I would have guessed that too. It wasn't. What was number one? Gentleness by the commercial beekeeper.
What was it?
Gentleness. Gentle bees.
Oh, gentle bees?
Why? Well, the average commercial beekeeper hired teenage boys to go out and work their bees routinely. I mean, they just had help. And they wanted gentle bees because these kids would quit if they got stung too much. And it was, and even for themselves, they said, if you've got a cranky colony, you go slow. And we can't afford to go slow. I mean, I've got 300 more colonies I got to look at today. And I got to do it fast. And so gentleness was number one. Honey production was not very far behind, but it wasn't number one. And I say that.
Every one of them are taking the honey off and feeding sugar syrup.
Sure. The whole economics of that is real. I mean, you can understand what they're talking about. I mean, if time is, what is it? Langstraw said, time is money, and to the bees it's honey, and but time is money. Yeah, Brad.
So in your opinion, Dave, how much does color of the bee really matter?
Let me answer it this way, Brad, okay? I suspect if you knew what you were doing and knew exactly what traits you thought Italians had, you could select for a very dark Italian, a black Italian. By the same token, I think you could select for a very light Caucasian. I showed you. But as a general rule, we don't sit down and say, well, the Italians had this kind of wax deposition trait, and they had this wing morphology and this leg morphology, and we just don't do that. What do we do? Well, this is a nice color bee, and I like it, and so I select on that. And so we really haven't selected for what we would consider Italian bee traits or Carniolan traits. But Dale.
Is there anything to the darker color bees warming up earlier in the spring?
The question is, is the dark bee got any evidence that dark bees that warm up quicker and they could fly quicker? There's some. I would say not overwhelming evidence, but there is some. That they can fly because of the radiant heat that they generate. They can fly a little earlier in the morning or a little colder weather than the yellow bee. Yeah.
Is there any thought, or has anybody done it, changing their entrance from the south side in the summertime to the east side in the wintertime by chance?
Most people don't because of the labor, but it's doable.
I'm just reading an article in here from Northern Illinois, and it sounds like, as they first glance at it, that's what they're doing with what he calls an insulation board on the north side.
Mm-hmm. Mm-hmm.
And it makes sense up here to me, but yet I like my entrances facing south.
Good point. Langstroth made a comment about piercing winds, and I think he's right, that we should try to keep the wind from hitting the bees as much as we can.
From the north and west.
Probably north and west. And so an ideal apiary site has trees on the west or north and faces south and east and gets the sun. Really perfect apiary would have probably late afternoon shade in the winter, but even midday shade in the summertime, so that they warm up in the morning. By noon, when it gets hot, now are in shade, and so they don't have to cool their hive and spend energy doing that. There aren't very many of these apiary sites. We take what we get when we can and hope for the best. Yeah, you go on to air drainage. There's all kinds of things we think about as for the perfect apiary site. Road access, you know, road access, loading dock. Had a friend in Canada, that's what he did. When he got a new yard, he went in, dug a sloping pit, which was his loading dock, lined it with gravel, made it drain in it. I mean, he didn't go into a yard until it was perfected. And then he could get into it year-round. And we don't do that.
Has anybody happened to see this article in Acres USA, August? Taking steps to prevent winter killing beehives by a Greg Sparks?
I see it.
Roger,
Okay.
I think your 50 minutes is up. Thank you.
That was-